Hi everyone, my name is Jamie. I'm a dev here in London at Pulselive. Welcome to my bedroom in South London. Today I'm going to talk about internet apps. It's going to be a lot of fun. So let's get right into it. Okay, yeah, I work here at Pulselive in London, and we make sports apps. So one of the projects we were involved in this year, was the Cricket World Cup. So we built the official website and application for the Cricket World Cup last year in 2019. So it's your traditional sort of sports apps you might see. So you get the news, videos, live scores, but also we built some sort of user engagement features. One of those was called a quiz. So the ICC who run the tournament could, at the end of the day after a game has been played, make a quiz of 10 questions that they could then push out to users. Users can then complete the quiz. At the end, they get like a score that they can then share with their friends. This feature was really nice and self-contained. And since users were sharing at the end, sharing their score and also a link to the quiz, we decided to try and make it an instant app experience where we can go, a friend shares their quiz result with you and the link. And when you click on the link, instead of opening the website, it'd be great to open the Android app and give them that great native app experience with all those slick animations without having to go through and install the application. So if you actually want to try this out now, you can. If you go find the ICC app on the Play Store and just click the Try Now button next to the install button, it will go launch the instant app for you. You can try out the quizzes if you're a cricket fan at all. You may notice that it's different to the screenshots I've just shown you. That's because the world of sport does move on pretty quickly, even in a coronavirus world. So it's no longer the Cricket World Cup application. The instant app you'll see is the T20 World Cup, which is hopefully in October this year. Maybe, maybe not, but we'll see. So yeah, here's the screenshots again. It's just, this is the final product of what we built, but actually it's not the interesting thing about what we did. We eventually got an instant app out the door, and it works great, and it's great for users, but it actually turned out to be very, very difficult to build an instant app for various reasons. We hit loads of problems about a year ago when building it. So today I just want to go through and show as many of the problems as I can and how we solve them C to C in a very real project. None of the solutions I'll show you will be like textbook solutions and very great samples, but they're solutions that we hit in a very, very real application and solve them like the best way we could for us. I've given a few variations of this talk over the last 6 months or so. So the instant we built like almost like a year ago now. And a year is a long time in the Android world. So as I've given variations of this talk, every time I've given the talk, one of the problems that I've talked about has been fixed or made better by some better tooling. So I'll discuss the problems anyway, and if they have been fixed or have been improved, then I'll just point you at the right versions to use that contain the fixes or some extra discussion around that. Before I really dive into the nitty-gritty details and technical detail, we need to sort of go over dynamic features in case you're not familiar with them at all. So dynamic features is the sort of family that instant apps now live in. So I'll just go through a very sort of basic introduction to dynamic features before we sort of dive into the instant app detail. So dynamic features are a new type of Gradle module, and they effectively give you complete control over when a feature in your application is installed. They come in 4 different flavors. So you can have a feature that's installed at install time. So this is a feature that's downloaded when the user installs your app from the Play Store. And this is like how you'd conventionally deliver an app. Everything is delivered when the user clicks install. So you can have a dynamic feature that's just set up to be installed at install time. Nothing different there. You can have a conditional dynamic feature. This is the same as above, where it's still installed when the user installs your app from the Play Store, but it's always subject to some conditions. So say you have a feature that only users on SDK 24 plus can use, but you support for the rest of your app down to like 21 or something, then you can set different conditions. You can say, okay, I need a device that has a camera. Need a device that has a camera. Need a device that has a say min-SK24, you can deliver that feature only to those people, and the people that can't run your feature don't actually install it, which is great. You also have instant enabled features. These are the new instant apps. So this is download this feature and just this feature when a user clicks on a web link. And you also have on-demand features. So I don't want to install this feature now when the user is installing from the Play Store, but I'm going to install it later when they navigate to that feature, for example. So if you have a large feature that's only used by a small portion of your user base, you don't want to have to install that when the user installs from the Play Store. You want to get that quick install time going. So you can install it later when the user actually tries to get to it. The core thing about daunting features is that you can actually also uninstall them. So for example, if you have an onboarding feature where you it's installed at install time, but once the user's gone through onboarding for the first time, they never see it again, you can actually uninstall it afterwards and keep your installed app size down to a minimum. So it gives you complete control over what features you install and when you install them. Obviously today we're going to just talk about instant apps, so features that are downloaded on their own without the rest of the application. So daunting features have to work in a way that they have to be separate from the application, and since they need to be installed, they may not be installed at install time, the application can't depend on them anyway, right? You have to guarantee that the feature and the application can run without the daunting feature being installed. So this flips the Gradle dependencies a little bit. So conventionally, you may have a Gradle diagram that looks like this. This is a clean arc standard diagram where you have the application module app, which is at the very, very top, and it depends on everything. If you look at a modularizer feature here, you may want to, you may look to like create a new library module, but ultimately it will still live below app. The difference with daunting features is that they actually sit on top. So they sit, instead of app depending on a feature, the feature depends on app. This is what enables daunting features to be downloaded away from install time, and they can run, and the rest of the app can run without them because the application has zero idea it exists. This produces some oddities in Android. Android has been relying on the fact that the application module is the top level module for the last 10 years or so. So probably adding another thing that goes on top of that produce some sort of oddities in the build system that I'll go through today. So backing up to this sort of like stock clean arc diagram, this is where we started Quick World Cup in about January last year. The problem we were having is that the app module is still very monolithic in the sense that every feature's in there. All right, we split up to the clean arc by layer here, but literally everything is still in app, and it's still a huge, huge application. At this point in January 2019, we were still shipping as APKs, not as app bundles. So yeah, at this point, it was a 56 megabyte APK install, which is absolutely huge. We'd already built out the quiz functionality, the thing we wanted to build into an instant app, and that lived in app at this point. So what we want to do is, okay, we want to take this quiz feature, make it an instant app, but for instant apps, there's a very, very small download size limit. So if you want to ship an instant app to users, they can't be downloaded at 56 megs, right? For an instant app, it's got to be instant. So there's a 4 megabyte instant app, 4 megabyte download size limit. Can you give me a second? My monitor's about to turn off because I haven't interacted with it for a few minutes. 1 second. Everyone, I'm just reconnecting my monitor. Give me 1 second. It turned off on me. Here we go. Here we go. Excuse me 1 second. What's there? Just stare at my beautiful face for a few more minutes. 1 second. Long. Cool. screen. There you go. There you go. Apologies, my monitor turned itself off. Very, very convenient. Thank you. Okay, so yeah, this is where we started, and we were struggling because the quiz feature lived here. We couldn't just instant enable the app currently. It was far, far too big and wouldn't fit in the 4 megabyte download size limit. So what we could have done is just bring quiz out into dynamic feature, like you should do for a dynamic feature. However, an instant app isn't magic. It still requires an application to install. So an instant app effectively is just a very, very small application. So if we'd have brought quiz out here to become a dynamic feature, when you install the instant app, it would still install the base application module too. So you'd still have this 56 megabytes. There's a car alarm going off. 56 megabytes app module that's far, far too big. So what we moved to instead is a split Gradle setup. So we moved the application class down to a new base module and left app where it was. We left app as this huge giant feature that's installed at install time on its own. We created a new module called base and pulled stuff from that only needs to be installed for the instant app down to this base application module. Basically, effectively, this was a very, very small module now. It just contained the custom application class. And then we could extend quiz into a dynamic feature that would be installed as part of the instant app. So how it looks for a user is that for when they install from the Play Store, they'd get everything like they would before. There's no change here. They'd get the whole of the app and the quiz feature. However, what it meant was when they installed the instant app, they would just install quiz. They'd install this very, very small base application, and they ignore the rest of the app, which is now a big dynamic feature. This is what enabled us to try and made it possible to get into the 4 megabyte limit. It's still very difficult, but at least like put in the realms of possibility. I'm going to talk a bit more detail about the 4 megabyte download limit. In my opinion, this is the single hardest problem that you need to solve if you want to make an instant app experience. And actually, this has changed in the last 3 weeks. And I'll go over that in a second. But as of 3 weeks ago, if you asked my opinion 3 weeks ago, this was the hardest thing you'd have to solve in order to get an instant app out the door. If you're starting with a big application like we did, our code base started from the Cricket World Cup 2015, so 5 years ago now. We have a load of features in there built over those 4 years. And all of a sudden, we were trying to get something out there that was just 4 megabytes, and that's not a lot of space at all. So I'll just give a breakdown of where our 4 megabytes went for our instant app. So Android X takes about 1.2 meg up, which is great. So a quarter of our 4 megabyte budget is gone already immediately by the platform. Then you chuck the material design label on top there. It's sort of 500 kilobytes. Then you got Firebase, which only means 60 kilobytes, but Firebase brings the entire Google Play services with it. So you have 750 kilobytes. So before we've even written a line of our application code here, we've already used over half our sort of 4 megabyte budget. Finally, we start adding some stuff from our project. So this is some assets. Obviously, we work a lot in sports, so we have a lot of heavily branded products, a load of images and stuff. So sort of common assets that are used across the app and quiz took about 500 kilobytes. Fonts, TTF files and OTF files are huge. So in the end, we had 200 kilobytes taken up just through proprietary fonts. Because they're proprietary, we couldn't use sort of downloadable fonts, so we were stuck with bundling the TTF files in, and they're huge. At one point, this was 300 kilobytes, and then I found that the medium italic version of the font was used by exactly one text view in one place. So I said to the designer, I'm sorry, I need those sort of 100 kilobytes. That medium italic is going to have to go. So I just changed the medium. No one noticed. But yeah, I managed to cut 100 kilobytes out just by removing a font that was used in one place in one text view. Then we actually get some codes. There's some common, this is our networking layer and our data layer downwards. Pretty sizey at 500 kilobytes. So at this point, I still haven't written anything for my instant app, and I've used almost all of my budget. By the time we get to the quiz feature itself, it's a measly 250 kilobytes, right? So we've used the feature itself with 250 kilobytes, but because all the rest of this stuff we have to bundle in with it, we get a total of 3.95 megabytes. We're 50 kilobytes under the 4 megabyte limit, even though our feature is just 250 kilobytes, right? Which is absolutely insane. If I need to find more space, the one in particular I'd look at is the sort of the common Cricket World Cup code. That's a sort of big bundle of common stuff that we use across the entire app, and a lot of it's not actually needed for the instant app. So if I need to save more space, that's where I'd look. This 4 megabytes is like I said, the single hardest problem you need to solve. It's so difficult to get from a huge application, get something down that's sort of you can cut out and be 4 megabytes. 3 weeks ago, Google changed this without announcing it. Last week, I went to fact check some of the stuff and to source some of the stuff I'm talking about today. And it's the documentation had changed. It's no longer 4 megabytes. They told no one about this. They just sort of changed the documentation. So instead of 4 megabytes, which is very hard to hit, you get a whole 15 megabytes now for an instant app, which is absolutely huge and game changing because most medium-sized applications with a little bit of effort can get under 15 megabytes. It's this single change that I discovered literally last week was changed 3 weeks ago by sort of the last change date on the docs. Means it's gonna be so much easier to make instant apps. And you'll see a lot of the problems that I talk about for the rest of this talk. A lot of our solutions were based around the fact that we were constrained to this 4 megabytes. And a lot of our decision making was guided by the fact we only had 4 megabytes to work with. So now it's 15 megabytes, and you have so much more freedom and so much more flexibility to try different solutions. So yeah, I'll be referencing this 15 megabytes again throughout this talk because this is game changing for instant apps. I want to talk a little bit about dependency injection. It's a huge topic in the Android sphere at the moment. Using dynamic feature modules changes a little bit about how you need to handle dependency injection. In particular, we hit a huge problem because rather ashamedly, we were using Dagger Android quite a lot in our project, and a lot of our project depend on Dagger Android a lot. We've since moved away from that for this very problem. But you're also going to hit this problem if you use a lot of if you use conventional Dagger, but you're set up with subcomponents, you're going to hit the same problem. And I'll show you. So this is our Gradle diagram again. Remember that we have a very small base application module, and we wanted to move the application class from app where it was previously. We're going to move it down to base. So the problem with this might be obvious at first glance. We have normal things for an application class. So we plant a timber tree, we initialize fabric, rest in peace. And this is fine. This can come down to the base application module because you're going to want these for your instant app anyway. So they're great, they can come down. The problem lies with the fact that we need to bring the app component with it. So if you ever use Dagger Android and set up an app component, you'll know how much an app component likes to know about everything. And if you use a subcomponent, you'll know the app component sort of works down. So the app component is at the top of a dependency tree. It knows about almost everything in your app. This is a huge problem, right? Because we want to move our application class down from app into this very small base module. So we want to move the app component down, but when we move the application class down, we move the app component down, and that tries to bring everything else with it, right? So that defeats the whole point of trying to get a very small base module because we don't want to take everything down. We just want like just the application class. So yeah, we're back at square one again. We're trying to get onto this 4 megabyte limit, but this app component wants to try and bring everything with it down to the base module. So we had a few discussions internally, and we came to a few sort of conclusions. One of the guiding factors of this is the fact that at this point we're about 2 months out from the World Cup starting, and that in working when you're building apps for live sport is that you can't move the deadline, right? The World Cup is starting in 2 months, regardless if the app is ready or not. So we had to make some very, very tough decisions based on that deadline. So what we did want to do is try and redo the Dagger graph, right? We could go through the entire app and strip out Dagger Android, but we are 2 months from the tournament starting, and there is no way we have time and the resource to be able to strip out and redo the entire Dagger graph. So what we really had to do is find a solution that touched the app module as little as possible. One thing we also realized is that very, very few things in our Dagger graph actually need to be singletons, and very few things needed to be application scoped, right? So most things in our app were stateless, so it didn't really matter if they were scoped to the application or not. There were a few things in there that were singletons that didn't need to be singletons. We also realized we don't actually need Dagger application. We weren't injecting anything into the application class, so we could just use a normal application class that created a Dagger component if we needed to. So what we proposed was the fact that we'd leave the app component in app, that this nasty app component that knows about far too much can stay in this monolith app module. We'd move the application class to base, and it would create a new singleton scoped core component. So the couple of things that actually needed to be a singleton be created by this core component. We'd then depend on the core component by app component, would then depend on core component for those sort of singletons. And we don't want to, we can leave app component to what it is, everything's stateless. So by unscoping it from the application, it's fine, it should work, other than these few things that need to be singletons. And instead of the app component being built by the application, instead we'd actually build it, the activities would initialize it. And this should be fine in theory, because if everything's stateless, it doesn't matter if the activity and it scopes the activity or it scopes the application, it should run the same. Appreciate this is not too easy to follow via text. So this diagram might be more helpful. So what's happening here is we have this in our base application module. We have a core component that scopes the application and provides our singletons. In that huge monolith app module, the app component is still there. It's now scoped to activities, and it depends on core components for some singletons. And with the same sort of setup in quiz, with a much, much smaller quiz component, scopes an activity, and also depends on core components for a few singletons. If you are using Dagger Android and you know you're going to hit this problem, I've actually written up a very lengthy blog post on some actual code samples and how we solve this. It provides some extra sort of config you may need to set up for your Dagger Android. If you're using just straight Dagger in your project and you are looking at dynamic features, then I can't suggest the Played sample app from Google enough. It's actually a very, very good sample about how to set up a dynamic feature project, and it's got a very, very good Dagger setup, in my opinion. One of the other problems you're going to run into is with manifest merging. So with a conventional library module, so if you imagine a conventional app that has a top-level app module and all the it depends on all these libraries, what happens is that all the Android manifests get merged up into the application one. So in your APK, you have one really long manifest. Well, what happens here when we have a dynamic feature module that depends on this on the application module? How does the manifest merge work? Well, the manifest still gets merged downwards. So with the libraries, it gets merged upwards. With your dynamic features, your dynamic feature manifest will be merged downwards into your application module. Which produces a few odd little things you need to be aware of. So say in our quiz instant dynamic feature, we have a quiz activity, and that quiz activity has a theme. What happens when you have this manifest is merged down, but these things don't exist, right? The quiz activity and theme exists in the dynamic feature. The manifest gets merged down, but these two things don't exist in the application module where the manifest now lives. So hopefully you'd hope that the build system was clever enough to work this out for you. Not quite. So the activity is fine. It's quite happy to have an activity that that doesn't exist. You could do that in your project now. If you go type in some garbage into your manifest, some activity, and it doesn't exist, you'll get some IDE like redness, but otherwise it's pretty fine. Oh, sorry, I'm lost. However, your new manifest in your application module references a quiz theme and it's this style resource that doesn't exist. This is where your compiler will throw an error and it goes, well, I don't know. I've got this new manifest here, but I have no idea what this style resource is. Unfortunately, there are very, very few ways around this. One of them is that you could just lazily just move all your styles to base. This would be fine then, because all your manifest gets merged and it can now find the quiz theme because the quiz theme now lives in base. This is kind of horrible because it breaks that separation as a concern, right? You don't have bits of your quiz feature in the quiz module and bits of it in base, and it's not very nice. It also threatens your 4 megabyte download size limit. So if you're moving all your styles down to base, and those styles reference fonts and images, like we have heavy branding, right? So all the images that are in our themes and styles have to come with it, and that's like threatens our 4 megabytes. Not a huge issue now. Now you got 15 to work with, but it was when we were doing it. There is an alternative to moving your styles to base, and you can create stub styles. So this concept comes from Played again, the Google sample app for dynamic features. What you do in base, you set up a very, very you set up an empty style that doesn't do anything, it doesn't override anything. It's just completely empty. And then in your dynamic feature, you actually give your implementation of the theme. And what this does is it satisfies the compiler. Because the compiler goes, oh, I can find this quiz theme. It's empty, but it's there. And at runtime, actually, your correct implementation we use, the quiz theme that actually implements your colors and your styles and stuff, is the one that gets used most of the time. So the caveats to this is that you must be shipping as that bundle. There is a bug where if you build as a universal APK, for some reason, it will use incorrect style. It will use the empty style. You'll get a crash at runtime saying this style doesn't override app compat theme. For some reason, building via split APKs versus universal APKs, there's a difference to how the manifests are merged and how the resourcing tables work. So that universal APK builds will use the wrong style and you'll get a crash. That'll be fine. We're shipping as that bundle, it's no problem. You need to think about how you distribute in your test apps or your test builds to QA. We were shipping as an app bundle, but we were giving universal APKs to QA because it was easier, which meant users were fine, but then the QA had a crash, they couldn't use it. And because there is no split install support on SDK 21, users, even if you upload as a bundle to the Play Store, users that are on SDK 19 or 20, for us, because we would be SDK 19, would receive universal APK builds. And those universal APK builds will be using the wrong stub style. So for us, unfortunately, we end up having to move all our styles to base, which is a real shame, but it meant we had an actual chance of shipping. However, 3.5 weeks ago, this was fixed in Bundletool 13.4. So you don't have to move all your styles to base. You can go with just the Played way of doing it, which is just use the stub styles. And regardless if you use a universal APK or you ship as an app bundle, it's fine. They'll all use the correct implementation, and the compiler will be happy because you've got stub style somewhere in base. However, we'll need to force your Gradle plugin to use Bundletool 13.4 because it's not the default yet as part of the general Gradle plugin. So it's pretty simple. You just need to add and force in your top level build.gradle, force it to use 13.4. You're going to also want to upgrade your Bundletool command line tool. So if you're building bundles in your CI or locally, make sure you upgrade Bundletool to 13.4. Obviously, you need to wait for the Play Store to update to 13.4 because they're the one building your APKs at the end of the day. That should be happening by now. They told me 3 weeks ago that it would be done in the next 2 weeks. So it should be up by now. It should be 13.4, but I don't know for certain. But if you want to read anything on that or follow that issue, they're the issues on the Bundletool GitHub. So my recommendation overall now for getting around this manifest merging issue is to use the stub styles that you can see from the played sample. It's in my opinion, the correct way to do it. One of the temptations you're going to get is you're going to want to, what we did was like we started moving quiz out to dynamic feature, and it was great. And then we were like, oh my words, we can make everything a dynamic feature, onboarding comes a dynamic feature, the video player we can pick an instant app out of. And there's this overwhelming temptation to make every feature a dynamic feature. That sounds great in theory. You're going to run into a couple of problems. The main one is that any dependency that 2 or more dynamic features depend on needs to actually also be dependent on by the base application. And the reason for that is because dynamic features can be installed at any time, the build system has no idea, has no way to guarantee if you've got 2 different libraries being dependent on by 2 different dynamic features, if the same version ends up running on the device. So to get around that, they force you to depend on it in the base module. This becomes an issue because you have a particularly large dependency, like say for us, it was the Chromecast Play Services library that we needed for both the video player dynamic feature and also the app, because we display the Chromecast button in other places. This meant the build system forced us to put that dependency in the base module, and now all of a sudden the quiz instant app, which needs to know nothing about Chromecast, suddenly has that dependency sort of inherently, and that big Google Play Services 750 kilobytes library is now being included in base, which threatens your sort of 4 megabyte limit again. So the way around that, so you can, this has been sort of remedied in Gradle plugin 4.0, so you can now have dependencies that depend on other so dynamic features that depend on other dynamic features. And what I mean by this is that here you have a very, very flat, dynamic features can only stand on their own. In Gradle plugin 4.0, you can actually have, say, app here depend on videos, which then depends on base, which will help work around this issue. But overall, my recommendation will be to only turn a feature into a dynamic feature if it's actually going to be either an instant app or be on demand or actually using dynamic features. If you're looking to modularize and it's not going to be an on-demand feature or an instant app feature, then just use a normal Android library. Yeah, so if you need to use feature on features, use an Android Gradle plugin 4.0. I've written a long blog post about this, about the different ways you can set up your feature and feature dependencies to work around certain issues. So definitely check that out. Obviously, this sort of issue is not as threatening if you've got 15 megabytes to work with. For us, it was an issue because all of a sudden this Chromecast dependency was far too big to fit in our instant app because we only had 4 megabytes to play with. Sort of run out of time, so I want to spend sort of last couple of minutes talking about permissions. So we have this quiz feature, right? And at the end, we get to share our result with our friends. So I want to share, I scored 8 out of 10 on this quiz. When we share that with our friends, it looks like this. It shares, I scored 7 out of 10. Here's a link to a quiz, and here's this infographic. This sort of like graphic is generated by the app. We just turn a view into a bitmap and share it. So we want to share this image as part of the sort of the workflow. But instant apps have a much, much smaller set of permissions than installed apps. So what in particular, we do have no access to external storage as an instant app. That permission gets auto-declined. So where previously we were saving this image to external storage and then sharing it with the intent there, we can't do it anymore. Okay, no problem. We'll switch to internal storage. But actually, we can't do that either. So there's like an artificial wall in between installed apps and instant apps. So as an instant app, you can't share an image to an installed app. There's like an artificial sandbox wall that Android won't let you cross. It's really annoying. So the suggested workaround is to use your backend and share a URL that links to the image instead, either by generating the image on the backend or uploading an image to a backend. For CVC in particular, we just decided to forget it and drop the image and just share the text. One thing you may want to check out is the changes in scope storage on 10.11. It's not something we've played with, but it might help you out, and you may be able to share an image that's stored in external storage through an Snap. I'm not sure. So if you want to do something like this, then you have to go read up on the scope storage changes. I'm going to finish with some quick fire tips. So we've got 3-4 minutes left. So if you have any questions, start getting them in now, and I'll get to them in a few minutes after these tips. So some of these are going to sound super obvious, but definitely double check your ProGuard rules. A lot of us are working with inherited code bases, but we didn't make the ProGuard rules. We got our internet down to like 6-7 megabytes. Like, how the hell are we going to find these extra 3 megabytes? And then we found a rogue ProGuard rule that was keeping far too much. And just by getting rid of that rule, we saved another megabyte. So it may sound silly, but please double check your ProGuard rules. Make sure there's nothing silly going on there. Back when we built this last year, we had the Android Gradle plugin 3.4 as the latest we could use, or the latest stable one. We found a lot less problems with 3.5. So for a long time, we were using 3.5 beta in production. So if you're still somehow on the old Gradle plugin versions, definitely bump to 3.5 or above. And I would even suggest bumping to the 4.0 beta if you want feature-on-feature dependencies. Another one that should sound obvious, but there's an APK analyzer in Android Studio. You just drag and drop APKs in. That's going to help you a lot in working out what's taking up a load of space in your APK. So if you've got large assets and stuff, it's going to it's going to sort them by sort of size. So you get like, oh, this particular image is taking up 300 kilobytes. What's that doing there? So definitely use the APK analyzer. You should also test when you build your APKs, use the highest density bucket. We were hit a point where we were below the 4.4 megabyte limit on MDPI, but we're above it on XXX HDPI. So when you're looking at trying to get under a download size limit, definitely use the highest bucket available. And the other thing is to use the internal test track, so you can test instant apps with no download size limit on the internal test track on Google Play. So definitely use that. However, you are subject to Google indexing. Obviously, Google needs to associate the web link with your instant app, and sometimes that can take up to 24 hours. So don't panic if you upload your instant app to the internal test track. It doesn't work straight away. Quite often, I have to like test it in the next morning after uploading a change. So yeah, you are at the mercy of Google indexing. Finally, I haven't got long left. I had this slide late. It's the question, should you build an instant app? Had you asked me 5-6 weeks ago, my answer would have been only build an instant app if you have a very, very small self-contained feature that works standalone, and you can make very, very small, and you can make under 4 megabytes. Now with 15 megabytes to play with, honestly, it means us at Pulselive are going to build lots and lots of instant apps this year, because 15 megabytes makes it so much easier. And honestly, the majority of our time was spent trying to get us under this 4 megabytes. And now you have 15 megabytes to play with. It actually shouldn't take an awful lot of time to build an instant app experience. So my opinion has changed over the last sort of 6 weeks or so, since all these changes came in. It's gone from only build one if you have something that really works in instant app to you probably should be building an instant app experience this year, because they're so easy to do now. Great, that's everything I have for you. 30 seconds left. I have a few posts on Medium and stuff about some more detail about some of these problems if you're interested. Otherwise, definitely go check out the Played sample app. It's not an instant app example, but it's a direct features example, and it is one of the Google's best samples across all their apps. So if you're interested in direct features at all, definitely go check out Played. Fantastic, thank you. I'll just move on to, you come back on me for a second. Thank you very much, and I'll answer any questions. I think I've got a little bit of time. Let me get some questions up. If there are any. Okay. Back to my screen. So admin, I'm just going to take the last 2 minutes of questions. Let's go through them. Okay, so are you planning on putting the medium font back in? The design's sort of forgotten about it, so no. We'll leave it as it is for now. It was one text view at the bottom of the page, so I'll leave it in. But what it does do is it means it doesn't stop us doing, if they want to build another font for another branding, for another tournament, it won't stop us, so we're not limited anymore. But that font for CBC will probably stay. So ProGuard enabled, disabled, that's all with ProGuard enabled. There's absolutely no chance you're going to get into under 4 megabytes with ProGuard disabled. So that Android X at 1.2, whatever it was, megabytes, that was with ProGuard enabled. It made it a little bit difficult to track down what was causing stuff, but yeah, it's yeah, no chance of getting under 4 megabytes with no ProGuard. And then one more question, because I think it's a good one. Do you create all apps as modular applications now, or depends on the size? Yeah, for us, I honestly think you shouldn't start with a modular application. Start with just, your application's going to start small, right? So start with just one module. As your team grows, as your application grows, so then you start thinking about modularizing. It's very, very easy to over modularize and make your life more difficult than it should be. So I think, in my opinion, you should definitely start with a single module project and then expand and modularize as you need to from there. Great. The last 2 questions I've run over time, so I'll answer the last 2 questions on Slack. Thank you very much, everyone. I'll see you around. Thank you.